Hey, everybody, and welcome to Socratic Med's week 8 of our 15-week MCAT supplement course. My name is Chris. Today I'm going to be talking about behavior, attitude, and learning and forgetting. So just a little bit about the organization, just a quick introduction for Socratic Med. We are a grassroots nonprofit, and we provide sensible solutions to students with disparate medical school opportunities. So we just provide some free resources when you're studying for the MCAT. Other resources for pre-med students. We have a bunch of videos online. We communicate with our students through GroupMe. So if you want to look at that link down there, you can get in touch with us that way. That link tree all the way at the bottom also has all of these links, and you can even sign up for office hours. We do 30-minute sessions of one-on-one virtual office hours. Everything's over Zoom and everything is free. So when you have a minute, you can definitely take a look at some of these links. So on a more personal note, my name is Chris. I graduated from Stony Brook in May of 2019 on a pre-med track, and my degree is in applied math and statistics. So I took the MCAT in April of 2021, and I got a 520, which for that test was the 97th percentile. And I did get a perfect score on the psych and soc section. So my tutoring specialties are usually biology, psych, and soc. So if you did want to do, any one-on-one tutoring, anything like that, go back to that link tree, and you can schedule some sessions through the Calendly link that we have up there. Okay, so we'll just dive right in. The first sort of section we're going to go over is attitude and behavior. So what is attitude? So in the realm of sociology and psychology, attitude can be defined as an individual's feelings, beliefs, and possibly behaviors toward other people or events. So that really is a pretty conclusive definition of what it is. And furthermore, attitudes are usually comprised of three components. So when we're talking about attitude, there are three aspects of attitude that we can look at to get a better, bigger picture. So the first one is affect, which is emotion. So it's basically how does the stimulus make us feel? How does the situation make us feel? If you look over to the right, the ABC model of attitudes, and we look at affective, feelings and emotion, composting is important to me. So if we're analyzing our attitude toward composting, the affective component, it might be composting is important to me. It makes me feel good. It makes me feel happy that I'm contributing to a greener earth. So any sort of emotion or feeling that is evoked from the stimulus or the event or people, that would be considered the affective component of attitude. The B is behavioral tendencies. So past and future activity. I compost wherever I go. So it's basically how we're acting with the attitude. So if we're talking about composting, our behavioral tendencies would be we like composting, so we do composting. Wherever we live, we compost. And then C is for cognition, or it's for thought. And it's basically just, our thoughts and beliefs on whatever we're looking at. So composting reduces CO2 emissions, for example. That's a pretty logical statement. And that might lead a lot of people to have a positive attitude toward recycling or toward composting. So those are referred to as the ABCs of attitude, and you should definitely be familiar with them for the MCAT, definitely. All right, a little more on attitude and behavior. So attitudes and behaviors may not always line up. Sometimes our behavior does match our attitude, sometimes it doesn't. For example, you may believe that going to the gym right after work is essential for a healthy lifestyle, but in reality, you take a nap on your couch every night before dinner. So our attitude, we know that the lifestyle is healthy, but for whatever reason, doesn't really even matter the reason. Sometimes our behavior just does not line up with the attitude. And we'll talk in a little bit about cognitive dissonance theory, and basically how our need to resolve that sort of dissonance between these two differences, how that sort of drives us to the behavior that we actually end up seeing. So although our attitudes often influence our behavior can also influence our attitude. So it's sort of a two-way street. So some examples of when behavior can first influence our attitude is role-playing, for example. So if you think of method acting, these actors truly try to get into their part. They're playing a role, and they become so enveloped in the role that their attitude actually changes because of the behavior that they're performing. Their behavior is that they're playing this role, and then their attitude actually starts to conform to the attitude of the role they're playing. And another example of that would be the Stanford Prison Study, which is a super famous study. I'm sure you've heard of it before. But in that study, Some of the students were actually, all the students were given roles to play, and it was discovered that students that were given the roles of corrections officers and that were instructed to, um, be very violent and very not fair toward the inmates, these sort of behaviors actually affected their attitude as well, and they were actually more likely to, believe in really harsh punishment, even for things that really they weren't deserved for. So definitely that Stanford prison study, you'll probably see that on the MCAT. That's definitely something good. Something good to know. You could definitely take a read into it if you have a couple of minutes. I mean, there are some controversies about it, but regardless of regardless of how legitimate the actual results are for the study, it's constantly talked about whenever we talk about attitude and behavior. So definitely make sure you know that. Public declarations make humans more likely, to believe that which they are declaring. So when we say something in public, it's just human nature that we are more likely to believe what we're saying if we say it publicly. If we make a public declaration, we're more likely to actually believe it. And then justification of effort is the other one, and it's when we modify our attitude to match our behavior. So for example, deciding to become a teacher after getting a 525 on your MCAT becomes much less likely when you think about how much effort you've already put in. So if we think about it, our behavior is the effort that we put in months and months and months studying for this MCAT. If we think about becoming a teacher, we're going to be a lot less likely to want to choose that just because of all of the effort that we put into this MCAT. If we hadn't put any of the effort into it and we were evaluating, should I be a doctor or should I be a teacher, it might be a different story. But because we had we added that behavioral component, the fact that we were studying for months and months, we put so much effort into it. Instead of adjusting our behavior, we modify our attitude. So we might convince ourselves that we actually do want to become a doctor and that it's actually much more worth becoming a doctor than it would be a teacher because we already put so much effort into it. So that's what justification of effort is. Okay, so cognitive dissonance we'll talk about really quickly. Cognitive dissonance theory aims to explain why self-justification has such a strong influence on attitude modification. So cognitive dissonance theory posits that we experience tension when we hold two ideas that are incompatible. So this tension is also known as dissonance, and it's that sort of cognitive tension that you feel when two things are in your mind that just don't make sense. So in the case of the current conversation, two ideas can be conflicting behaviors with attitudes. So when we aren't thinking, when what we are thinking doesn't align with what we're doing, we start to feel that tension. So if you've ever been doing something, for example, if you've ever just been doing anything and you stop right in the middle of it and you're saying, why am I doing this? That's sort of cognitive dissonance, because in that very moment, your behavior is not lining up with your attitude. So in that very moment, you might realize there's no reason I should be doing this. So your attitude changes and it's no longer congruent with your behavior. So because you are performing a behavior that you do not believe to be important, you feel this dissonance and we feel this tension. So we have to alleviate that tension because we don't like it. So you can either change your attitude or you can change your behavior so that they line up. And that's really what cognitive dissonance theory is, and that's really why it's so powerful. It's just that we change our behavior and we change our attitude just to reduce this tension when we hold incompatible thoughts in our mind. All right, and that brings us to the first review question. So which of the following would not help explain a child's attitude toward dogs according to the three components of attitude? Read this over, take about a minute. I would pause the video because I'm going to go over it in a couple of seconds. Let's review. So which of the following would not help explain a child's attitude toward dogs according to the three components of attitude? So the correct answer is D, the child does not like cats. So if we remember the components of attitude, we're talking about the ABCs. We have the affect, which is the emotional component, B, their behavioral tendencies, and then C is the cognitive component, which is our thoughts, our beliefs. So we can look at the child's attitude toward the dog. We can explain this through these three components. So the child is frightened by the sound of growling dogs. Your tip-off word right there should be frightened. That is an emotion. So we're talking about affect. We're talking about the affective component. So that is true. So it would help explain the child's attitude. So A is not correct. B, the child recalls multiple negative past experiences with dogs. That would be considered cognitive. Anything having to do with learning, memory, ideas, opinions, that's all cognitive. So this child is using its past experiences and it's evaluating the dog in present time. So from a cognitive, from a cognitive component, this is also helping explain the child's attitude toward dogs. And C, the child tends to cry and run away when she spots a dog. So that's going to be B, the behavioral tendencies, because it's a behavior. So it's how the dog reacts to the stimulus. I'm sorry, it's how the child reacts to the stimulus, which is the dog. So child is scared, child's going to cry and run away when she spots a dog. So that is also going to explain the attitude of the child when we're talking about the dog. The only thing that doesn't really explain it is D, the child does not like cats. That could be true, that could not be true, but it doesn't really incorporate anything having to do with the ABCs of attitude, and it doesn't really explain the child's attitude toward the dog. So that's why D is not correct. And again, if you ever have any questions or you have any comments about these questions, about anything I'm going over, I'll post my email again at the end. Just always shoot me an email. I'll definitely give you a quick answer, or you can join that group me and ask questions. We have students and tutors answering questions in live time 24/7. Okay, so the next topic we're going to talk about is learning and forgetting. And the first type of learning we will talk about is non-associative learning, which is not super high yield, but it's pretty easy. So I definitely think you should know it for the MCAT. So non-associative learning occurs when an organism is repeatedly exposed to a stimulus. And the two types that may appear on the MCAT are habituation and sensitization. So these are always the two that you're going to hear about when we're talking about non-associative learning. It's going to be habituation and dishabituation, and then we have sensitization and desensitization. So let's talk about habituation first. And that's when an organism learns to tune out a repeated stimulus, or when the response to a stimulus decreases due to repeated exposure. So it's that really happens. This happens to us all day, every day. So imagine if you enter a house where someone just baked cookies. As soon as you walk into the house, you're going to smell the vanilla, you're going to smell the chocolate chips really strong. But after 5 or 10 minutes, you're not really going to smell anything new anymore. It's just going to go, your nose is going to go blind. So that's what habituation is. We're sort of turning out a repeated stimulus because we're constantly exposed to this smell. So at a certain point, our body just doesn't really have a need to respond to the stimulus anymore. So we do learn to tune it out, and that's called habituation. Dishabituation is sort of the undoing of habituation, and it occurs when the stimulus is removed. So if we're talking about our cookie example again, once we leave the house, we're not going to be smelling cookies anymore. So we are going to become dishabituated to that stimulus, which is the smell. So when the organism is again presented with the same stimulus after dishabituation, it will react as if the stimulus is new and may elicit even stronger response. So that means after dishabituation, after we leave that house, when we come back in, habituation can occur again. So we're going to react as if the stimulus is new, so as if we've never smelled it, and we might even elicit a stronger response when we smell it, just because that's just how dishabituation works. And then the other sort of opposite of habituation is sensitization. So when an organism elicits an increased response to repeated stimulus exposure. So habituation is when the response decreases with repeated stimulus exposure. Sensitization is when it increases. So it's essentially the opposite of habituation. And then desensitization is the same thing. So like the opposite of sensitization. It occurs when the stimulus is removed. The organism will then react to the stimulus as new. So for example, one of the better examples I saw for this was if you're watching a horror movie, you are going to be sensitized to those sort of scary stimuli and those sort of jump scares. So if you're done watching a horror movie and you leave, and one of your friends is waiting outside of your door and tries to jump and scare you, you are going to be a lot more scared after watching the movie than you would be before watching the movie, because you're sensitized to it. You have had an increased exposure to these sort of scary jump scares all day, so now you're sensitized, and you're going to actually elicit a stronger response to a similar stimulus. And then desensitization, obviously, say you go to bed and you wake up the morning after, you're going to be desensitized, because as time passes, we pretty much desensitize to stuff like this. And then once desensitization occurs, sensitization again is possible. Okay, so we talked a little bit about non-associative learning. So now associative learning, which are the really important types. So the first one is classical conditioning, which I'm sure we've gone over. This little diagram to the left is the most popular example, Pavlov's dog. So the first type of associative learning is classical conditioning, and that's a process in which two stimuli are paired such that the response to one of them changes. So if we look to the left, we have before conditioning. So we look at the top left, this box right over here, we have an unconditioned stimulus, which is the food, and then the unconditioned response. The unconditioned response is what happens when the dog is exposed to the unconditioned stimulus. So this is usually like something instinctive or something inherent. So food is the unconditioned stimulus. It's going to cause the dog to salivate, which would be the unconditioned response. We didn't teach the dog to do that. It's just on a biological basis. This is the response that the stimulus is going to elicit from the dog. We then have a neutral stimulus. In this case, it was a bell. So every time Pavlov would feed his dogs, he would ring a bell. So eventually the dogs learned to associate the bell with feeding, and they would salivate before food was even given out every time they heard the bell. So before the actual conditioning occurs, the bell is considered a neutral stimulus, because if we ring the bell and the dog has not learned to pair it with food, there's not going to be a response. The dog will not respond to the neutral stimulus. That's why we call it neutral. So during conditioning, we take that neutral stimulus and we pair it with the unconditioned stimulus. So every time we ring the bell, we're going to give the dog food. That unconditioned response is going to be in response to the food. But since we're pairing the food and the bell, after conditioning, that conditioned stimulus, the bell, is going to elicit a conditioned response, which is salivating, just from the bell alone. So that's how classical conditioning works. It's just basic association of two stimuli. Yeah, so the neutral stimulus becomes conditioned and that elicits a response. So the sound of the bell alone will eventually cause the dogs to salivate. Okay, and then associative learning. So these are just some important words and phrases that you should understand. So when we say acquisition, we're talking about the process by which an organism pairs two stimuli to form a conditioned response. So acquisition is the actual act of pairing the stimuli. Extinction refers to the process by which a conditioned response is unpaired from its stimulus. This usually occurs by presenting the conditioned stimulus repeatedly without the unconditioned stimulus. So if we're talking about our Pavlov's dog example again, acquisition would be the process by which we are pairing the food with the bell. So that would be acquisition. So once we get that neutral stimulus of the bell, once that becomes a conditioned stimulus, we would say that that behavior was acquired. The salivation from the bell was acquired. And then extinction is the opposite. If we continuously ring that bell and we don't present the dog with food, eventually the dog is going to learn to unpair these two stimuli. So extinction, eventually we would ring that bell and the dog would stop salivating because it would know that there's no food coming anymore. And then spontaneous recovery, interestingly, is the spontaneous reacquisition of a conditioned response to a stimulus after it has gone extinct. So this does not involve acquisition. This is just something that happens after a behavior is thought to be completely extinct. It will randomly and spontaneously just recover, which is very interesting, but that's just how it happens. Generalization is the process by which a conditioned stimulus is broadened to the point where similar but distinct stimuli cause the same response. So generalization, if we're using a specific bell to get these dogs to salivate, if the dogs salivate when they hear something else similar, like a phone ringing, or if they start to salivate when they hear silverware clinging together, that would be considered generalization because we're broadening the stimuli that caused that response. We're adding more stimuli that would cause that response, whereas discrimination is the exact opposite. So that's when we're trying to differentiate the stimuli. So if we had those three, if the dogs reacted to the cell phone, to the actual bell, and to the loose silverware, and we wanted them only to react to the bell, we would play all of those. We would let all of those stimuli, we would let the sound come out, but we would only pair one of them with the actual unconditioned stimulus, with the food. So if we did that with the bell, eventually the dogs would be able to discriminate between the three stimuli and know that only hearing the bell means that they're about to get some food. So that is considered discrimination, and that's how you would teach discrimination. So associative learning, we have operant conditioning, which is the more complex of the two types of associative learning. So what operant conditioning does is it molds behavior using reinforcement or punishment. So there are two types of each, and it's important that you conceptually understand the difference between reinforcement and punishment, and also understand the difference between how we're using the words positive and negative. So in the context of reinforcement and punishment, this is very important. Positive and negative have nothing to do with the actual pleasure of the outcome. They have nothing to do with the fact that it is either a good outcome or a bad outcome. When we say positive, as in positive reinforcement or as in positive punishment, it means we are giving something. So in positive reinforcement, we are presenting a reward. In positive punishment, we are presenting a punishment. So when something is negative, it means we're taking away. So for negative reinforcement, we are taking away an undesirable stimulus. And during negative punishment, we are taking away a desirable stimulus. So we're going to go through each of them individually so that we can sort of process just exactly what that means. So we'll start with positive reinforcement, which is the most, probably the easiest to understand conceptually. And it's basically just a reward is presented to the subject after a desired behavior is performed. So they say you're trying to teach a dog to sit. Whenever the dog sits, you give it a treat. That's positive reinforcement. That's really all it is. We're just adding a desirable outcome. I'm sorry, we are presenting a reward every time we see a desirable outcome. So our desirable outcome in this case is that the dog is sitting. When the dog sits, we give them a reward. So negative reinforcement is we are taking away an undesirable stimulus. So it's the same goal as positive reinforcement. We are trying to reinforce a specific behavior. We are trying to keep the behavior. Positive reinforcement, we're giving them a reward. Negative reinforcement, we're taking something away that is undesirable from them. So if we have a dog again, say we're letting our dog out right before we go to bed, and it's raining. So the dog is outside and is getting really wet and wants to come in, but you're not going to let the dog in until it pees. So that's sort of negative reinforcement because the dog does not want to be in the rain. So the dog will learn once he pees, he can come back inside. So that would be considered negative reinforcement because we're taking away an undesirable stimulus as a reward. That technically would be considered our reward. So we want that behavior to be performed. So that's what negative reinforcement is. Punishment is sort of like the other side of the coin. It's the process that discourages a behavior by pairing it with an unpleasant outcome. So it can also be positive or negative. So punishment, if the dog does something bad, positive punishment. We put the dog in the cage, say. I'm not a dog trainer. I'm not saying that that is a good thing to do, but I'm saying for our example, positive punishment, we are adding an undesirable stimulus. So they do something wrong. We put them in the cage because we know they don't like the cage. During negative punishment, we're taking away something that's good. So we'll use an example of a kid, say the kid does really bad on his test and his mom takes away his video game privileges for a week. That would be considered negative punishment because she's not adding a punishment to him. She's taking away something that he likes. So that is considered negative punishment because we are trying to discourage that undesired behavior, whatever he did. So if he did bad on his test, negative punishment, we're taking away something that he likes for a little bit because we're trying to get rid of that undesired behavior. And then just really quickly, we have primary and secondary reinforcers. So primary reinforcers are unconditioned stimuli, like we spoke a little before, that are inherently desirable. So those usually have like sort of biological connotation. So it's usually food, water, sex, sometimes sleep. Those are primary reinforcers that we don't need to condition. And then secondary reinforcers are conditioned stimuli that are paired with primary reinforcers to become desirable. So for example, coupons to your favorite restaurant. If you're presented with them, you don't know what the restaurant is, you don't even know what a coupon is, you're not going to really care about it because you don't know what it is. You don't understand the value that it holds. But if you really love the restaurant and you understand what these coupons are and you're going next week, they're going to be a pretty strong reinforcer because, it's context and it's something that you want at that point. Okay, so reinforcement schedules we'll talk a little bit about. So there are different reinforcement schedules on which operant conditioning can occur successfully. So this is just the way someone chooses to carry out operant conditioning. So on a continuous reinforcement schedule, the behavior is rewarded after every occurrence. So when I say occurrence, I mean every time the behavior happens. This schedule will result in very quick acquisition of a behavior, but it can also result in quick extinction. So if you reward the dog for sitting every single time, they will probably get it in a few days. They'll probably learn it very quickly. But if you stop giving the dog treats every time the dog sits, it will forget the behavior very quickly. is basically just what continuous reinforcement schedule is. Whereas we have intermittent reinforcement schedule as well, the behavior is rewarded only after some occurrences, but not all. So this schedule results in slower acquisition of the behavior, but the learned behavior will persist. So it's going to resist extinction for a lot longer. So that would be if you teach the dog how to sit and you give them a treat every fourth time they sit. That would be considered an intermittent reinforcement schedule, because you are not presenting a reward every single time the dog does it. You're only presenting it intermittently. And this intuitively, it results in slower acquisition of the actual behavior. But once that behavior is acquired, the organism will hold it for a much longer time. Okay. So on the intermittent reinforcement schedule, so there are actually 4 intermittent reinforcement schedules, and these are the 4. We'll just go over them really quickly. So fixed ratio schedule is the one that we were just talking about, the one that I was talking about. That's when the behavior is rewarded every certain amount of times the behavior is performed. Whereas variable ratio schedule is the behavior is rewarded after an unpredictable number of times. So gambling is an example. The reason why gambling is so addictive is because we are constantly waiting for that reward. We don't know if it's going to come in one turn if we're playing blackjack. We don't know if we're going to win in the next hand, the next 2 hands, the next 3 hands, but when we win, it feels great. So that's really what the variable ratio schedule is. It's just rewarding after an unpredictable number of times because we're looking for that reward. So that also does cause a pretty strong response. A fixed interval schedule is the behavior is rewarded at set time intervals, regardless of how many times it's performed during these intervals. So if I only give my dog a treat every hour on the hour for sitting, it doesn't matter how many times they sit within the hour, they're only going to get it at that hour. And the dog will eventually learn this. So we'll actually, the response to the stimuli that are presented to the dog that are far away from the interval where they're going to get a treat, the behavior is actually not as strong. The response to the stimulus is actually not as strong. And what I mean is, if we are giving our dog a treat at 1 p.m., at 2 p.m., at 2:30 p.m., at 3 p.m., at 1 p.m., that dog is going to sit. I'm going to give him a treat. And then he's going to sit at 1:05. I'm not going to give him a treat. He's going to sit at 1:10. I'm not going to give him a treat until 2 o'clock. When he sits, I'm going to do it again. That dog will start to understand that he is only going to get treats when he sits at a certain amount of times. So he will be less likely to sit for a long time after he gets a treat, because he's understanding that he's not going to get another treat for a while. And then variable interval schedule, the behavior is rewarded at random time intervals. So it's the same thing, only it's not fixed time. It's just at random times, regardless of how many times the behavior is performed, as long as it is performed at least once. So if a boss walks by his office at random times throughout the day, the employee working there will display constant effort. So it's not like fixed interval, where if our boss was coming in every hour on the hour, we would make sure that we are doing our best every single time that boss walks in. We don't know when the boss is walking in, so we're going to have constant effort displayed throughout the entire time, because he may be coming in at any certain point. A little more on associative learning. So shaping refers to the reinforcement of small stepwise behaviors to teach an organism a more complex behavior. Again, talking about dogs, if you've ever taught a dog how to roll over, shaping is a way that we usually do that. You'll usually teach the dog how to sit, then you can teach the dog how to lay down. Then from there, you'll teach the dog how to roll over on his side. And then from there, you'll teach him how to roll over completely. And then, you attach that to one command, and that's basically how shaping works. And that pigeon to the right, that diagram, step 1, we give the pigeon food when it turns toward the button. Step 2, we give the pigeon food when it walks toward the button. Step 3, we give the pigeon food when it raises its head to the height of the button. Step 4, we give the pigeon food when it taps. So we're rewarding little behaviors so that the animal learns this one continuous complex behavior. And then we have 2 other types of learning. The first one is called escape learning, and that refers to learning a behavior that helps escape an aversive stimulus, obviously. So a child that finds herself suddenly outside in a storm will seek shelter to get out of the rain. So that's kind of like our dog in the rain example that we used when we were talking about negative reinforcement. And escape learning can be negative reinforcement. So in this case, it is. She's trying to get out of a bad situation, so she learns I need to seek shelter to get out of the rain, and that's how I get out of this situation. Then avoidance learning refers to learning a behavior that helps avoid averse stimuli before exposure. So that same child eventually is going to learn that when she walks outside, if she looks up and she sees dark skies during the daytime, it's probably not a good idea to go outside. So that is avoidance learning. Okay, memory dysfunctions. These aren't super high yield, but the two most common ones are not hard to know, so you definitely should know them because Alzheimer's definitely does pop up on the MCAT. So two of the more popular ones that they see are Alzheimer's disease and Korsakoff syndrome. So Alzheimer's disease is one that slowly destroys cognitive functioning and eventually the ability to carry out activities of daily living. So as Alzheimer's progresses, clumps of proteins called amyloid plaques and tangled bundles of nerve fibers called neurofibrillary tangles. They're also called tau tangles, as in the Greek letter. So these clumps and tangled bundles of nerve fibers, they become increasingly present in the brain, and that's basically how this cognitive decay occurs. It's because of the buildup of these plaques and these tangled bundles. So Alzheimer's is actually currently ranked the 6th most common cause of death in America, and it could honestly be even more. But that's pretty much, in terms of the MCAT, in terms of the scope of the MCAT, that's pretty much what we're talking about when we're talking about Alzheimer's disease. Just that one of the main symptoms of it is usually some type of dementia. It is a debilitating disease. It stops cognitive functioning. It stops your ability to carry out activities of daily living. And then those amyloid plaques are super important to know when we're talking about Alzheimer's as well, that there are a bunch of unfolded or misfolded proteins that clump together in the brain and cause issues, basically. And Korsakoff syndrome is similar in terms of the dementia aspect. It affects memory function, and it's believed to be caused by thiamine deficiency, which is vitamin B1. And it just has to do with cognitive functioning, with the way our brain processes glucose. So this is most commonly found in cases of alcohol abuse, but it can also happen in other conditions like cancer. AIDS can also cause it. The incidence level of Korsakoff syndrome is much lower than Alzheimer's. Okay, one more review time. Read that and pause. Take about a minute, maybe a minute and a half for this one, and then unpause and we'll go over it. Okay, so which of the following are not examples of negative punishment? So our correct answer is going to be D. That's Roman numeral 1, 3, and 4. So let's review all of the Roman numerals. So 1, buckling your seatbelt to stop the annoying beeping in your car. So if we look at what is going on, the annoying beeping in the car is the stimulus. So we're buckling our seatbelt to get rid of the annoying beeping. Buckling our seatbelt is the behavior that we want, and we are stopping the annoying beeping. So that would be negative reinforcement, because the beeping is reinforcing the behavior of buckling our seatbelt. So it's not a punishment, it is a reinforcement. Remember the difference between punishment and reinforcement. It's negative reinforcement because we're taking away an aversive stimulus, which would be the beeping. So when you put your seatbelt in, the beeping stops, everybody's happy. So 1 is not an example of negative punishment. So 1 would be true. 2, a parent takes away their child's video game privileges for a week for not doing their homework. I actually did just use this. I just used this example a couple of minutes ago. So that actually is an example of negative punishment because we're taking something away that the child likes. So that would be an example of negative punishment. A dog is given a treat for properly obeying the word come. That is positive reinforcement. That's one of the easier ones to identify. Dog does something good, we give them a reward. So 3 would be correct, and 4, a cat is sprayed with a water bottle after it stole food off of a plate. So that would be negative. That would be positive punishment because stealing food is a behavior that we are trying to discourage. So we spray them with the water bottle, which would be a punishment. And since we're adding that punishment, it's positive punishment. So 1, 3, and 4 would be correct. The correct answer is D. Cognition and biology in learning. We are almost done here. So behaviorism, introduced by B.F. Skinner, explains classical and operant conditioning, but it does not explain more complex forms of learning. So there are other forms beside the basic non-associative and associative learning that we just talked about. There are other forms of learning. We don't always learn by pairing stimuli, and we don't always learn by getting rewards when we do something good and by getting punishments when we do something bad. That's just not how the world works all the time. And behaviorism, B.F. Skinner's theory, as the 20th century went on, behaviorism was not able to explain some of the things that a lot of the newer cognitive psychologists were looking at. So that's why cognitive psychology really took over. And there's sort of an increased emphasis on looking at the mind and the brain, including behavior. So insight learning, for example, is something that would not have been able to be explained by behaviorism. So that occurs when previously learned behaviors are suddenly combined in unique and useful ways. So a child may learn to use a grabbing tool for fun, but finds that she can stand on her toes and reach up with the tool to grab things she normally could not. So she probably did not see someone doing this. She probably was not rewarded when she did this. But it came to her in an insight, and she realized that she could use other behaviors to accomplish something. And latent learning is another type where behaviors learn, but it's not necessarily expressed until it's needed. So a child may passively learn the way to his school, but is not going to express the knowledge until he finally walks there alone. So that's a sort of passive learning that we're all doing every day, but that children do at an alarming rate. Some biological factors. So learning, obviously, you could probably intuit that it's constrained by biological factors. So blatant example, a chimpanzee could never learn to speak because of neural and anatomical reasons, just neural and anatomical differences than humans. So reinforcers with biological relevance, like food or sex, like we talked before, they tend to enforce learned behaviors more quickly. So those primary reinforcers are a lot better at rewarding and reinforcing behavior than secondary reinforcers would be. The process of learning involves physical changes to your nervous system. During long-term potentiation, the synaptic strength between two neurons that fire are strengthened, creating a new neural pathway that is thought to transfer information into long-term memory. So the way that our neurons fire and the way that they're wired actually change when we encode things in long-term memory. So that's really all long-term potentiation is. That's really all you have to know about it for the MCAT. So we should also keep in mind that behaviors may also be biologically innate. So these instinctive behaviors are not taught, and they're usually shared among those of the same species. So, all baby humans are going to have very similar instinctive behaviors, just like all puppies are going to have the same instinctive behaviors. A little bit about mirror neurons. Humans have mirror neurons, which are specific sets of neurons that fire when an action is performed and when that action is only observed. So it's the same neuron. It's firing when the action is performed and when it's observed. Mirror neurons are still not completely understood, but there are some hypotheses that explain their importance. So, for example, one hypothesis says that mirror neurons help connect the sight and action of a movement. So that is more of like a biological paradigm. We're talking about the coordination of movement with sight. And the other one that's I would say more relevant for psychology and sociology is that it's been hypothesized that mirror neurons in the mirror neuron system are responsible for empathy and other sort of vicarious emotions in primates. So some people believe that because we have this mirror neuron system, that is why we are able to experience the emotions that other people are experiencing. It's all hypotheses and none of it has been proven yet. But this is about as in-depth that the MCAT will go on mirror neurons, unless it's presented to you in a passage. Okay, observational learning. So humans can also learn through observational learning, and most basically, we learn observationally by modeling. So modeling is imitating behaviors that we have previously observed. Albert Bandura had a series of experiments, and he demonstrated how predisposed humans are to observational learning and how much it actually affects our behavior. So in his studies, he showed young children videos of adults acting either aggressively or ignoring the Bobo doll. So the Bobo doll is that sort of large doll that when you punch it, it falls over. It has a strong center of gravity. So when you punch it, it pops right back up. So he wanted to see how children would change their behavior when they saw adults acting differently with these dolls. So he showed these young children the videos of adults. And even when the children did not see the consequences of the actions, they tended to mimic the actions that they saw on the video when presented with the Bobo doll in person. So but they may not have even known why they were doing it. They may not have even known the consequences of their actions. But if they saw a video of an adult acting aggressively toward the Bobo doll, when they were presented with it, they were more likely to also act aggressively. So these studies, from these studies, Bandura formed his social cognitive theory, which holds that humans can learn behaviors and consequences from observing others in a social context, kind of exactly like they did this. If it's a new social situation, we are going to learn behaviors based on other observations. And another review question. So which of the following statements is false? Take a minute, read those over, and we will go over it. So which of the following statements is false? The correct answer is B. Latent learning is a type of operant conditioning in which no punishment is used. So let's go over the correct answers. Correct answer. So insight learning occurs when two previously learned behaviors, that should say, are suddenly combined to execute a more complex behavior, which is true. We just talked about that. We had the diagram of the pigeon before. We reward it when it steps up. We reward it when it walks toward the button. We reward it when it presses the button. And that all is combined, and it teaches a more complex behavior. C, Albert Bandura's Bobo experiments gave much insight to the role observational learning plays in child behavior. It definitely did. As we were just talking about, it was super important. And it really allowed us to understand just exactly how child behavior, sort of how it works in terms of modeling and in terms of observation. And D, also, animals do not have to learn instinctive behavior. It is biologically programmed from birth, which is true. It's inherent. That's really the definition of instinctive behavior. So the only one that's really false is latent learning is a type of operant conditioning in which no punishment is used, which is not true. Latent learning is not operant conditioning. That's really that. Latent learning is more passive. We're not using operant conditioning. We are not rewarding or punishing actions. So B is false, which would make it the correct answer for this question. And that is all I have for today. I didn't have too much material for today, but that is my email again. If you guys have any questions at all, shoot me an email. I will try to get back to you within 24 hours. If you want to be added to the GroupMe, again, shoot me an email. I can send you the link. If you have any questions about how any of this works, about how any of the office hours work, anything like that, if you need any tips for studying, anything like that, please do not hesitate to give me an email. Other than that, I hope you guys have a great time studying, and check back next week because we will upload 2 more videos Sunday night. All right, guys, have a good one.